week 3 of our online distance learning, and this week we're going to be covering 10.2 arithmetic sequences and series. All right, so a sequence whose consecutive terms have a common difference is called an arithmetic. Arithmetic sequence. Consecutive terms means that they go in order. One term right after the other. Okay. A1, A2, A3, A4, all the way to AN, and it continues on. So this you should be familiar with from the previous lesson that we identified what the 1 would mean, what the 2 would mean, and what A1, A2 would mean. Why is that significant? All right, common difference, and we use the letter D to reference common difference, is a number such that the sequence is arithmetic if the first term minus the second term, the second term minus the first term is equal to the third term minus the second term, which is also equal to the fourth term minus the third term. Hopefully you get the picture, is equal to D. That difference between the numbers. How do I go from one number to the next? You always take the last term minus its previous term, and that gives you the D. And we're going to go through some examples of that. All right, for the first example, we're going to be understanding what common difference is and how to find it. Example 1A says the sequence whose nth term is 4n plus 3 is arithmetic. For the sequence, the common difference between consecutive terms is 4. Well, how did I know that? There are two ways in order to establish this. First, looking at any terms in consecutive order. So either I'm going to look at the first two or the next two, or the next two after that. So I'm either going to look at 7 and 11, 11 and 15, or 15 and 19. So they have to be in consecutive terms. And what you do is you take the second term, which is 11, and you subtract the previous term from it. Okay, so 11 minus 7 is 4. No matter which two consecutive terms you take, you should be able to find what the common difference is. So what if I take the last two terms? Same thing, I take the last term, which is 19, minus its previous term, which is 15, and 19 minus 15 is 4. Another way that you may have recognized already what the common difference is by looking at the number that's in front of n. Okay, that number, which is the coefficient of n, is going to be your common difference, or D. So this is the coefficient of n. Okay, so we would say that D is equal to 4. All right, on the next example, the sequence whose nth term is 7 minus 5n is arithmetic. For this sequence, the common difference between consecutive terms is -5. Again, one easy way to do this is by looking at the equation, and the equation has a coefficient of -5, therefore the D is -5. If you don't have the equation, okay, then you can look at the terms. Make sure you pick two consecutive terms. So if I pick the first two consecutive terms, I'm going to take the last term, which is -3, minus its previous term, which is 2, and 3 minus 2 is -5. I can take -3 and -8, for instance, and do the same thing. I'm going to take -8 minus its previous term, which is -3, and -8 minus -3 is -5. Okay. The sequence whose nth term is 1/4 times n plus 3 is arithmetic. For this sequence, the common difference between consecutive terms is 1/4. So again, if I'm looking at 1/4 times n plus 3, the first thing I want to make sure I do is simplify this, and you simplify it by distributing that -1/4 to everything in parentheses behind it. So I have 1/4 n plus 3/4, because 1/4 times 3 is 3/4. Now I can see that the coefficient of n is 1/4. and therefore I'm able to verify that the common difference is 1/4. You can also figure out what the first term is by substituting 1 for n. So it'll be 1/4 times 1 plus 3/4, which will give you 1. And then you substitute 2, you get 5/4. If you substitute 3, you will get 3/2. If you substitute 4, you will get 7/4, and so on. That's just by substituting what the first term, second term, third term, and fourth term is. All right, and if you were to find the difference between the first two consecutive terms, 5/4 minus 1 is 1/4. And then this introduces a new pattern. It's called the nth term of the arithmetic sequence. This is the format for how you see all the equations written. A sub n is equal to a1 plus d times n minus 1, where d is the common difference between consecutive terms of the sequence and a1 is the first term. So in order for this dynamic to work, you need two things. You need a1 and you need to know what d is. So I need to know what the first term is, and I need to know what the common difference between the terms are. All right. Example number 2, finding the nth term of an arithmetic sequence. Find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So back what we just discussed when we were looking at the formula, a sub n equals a sub 1 plus d times n minus 1, there are two things that I need to know. I need to know what the common difference is, and I need to know what the first term is. Common difference is the d. First term is a1. Common difference. A1 is the first term. And it gave you the information that you needed in the write-up. It said the common difference is 3 and the first term is 2. So all you need to do now is just substitute. A1 is 2. D is 3. And so the formula for the nth term, because we need to do a little bit of simplifying here, I'm going to rewrite that problem up at the top. Following rules of PEMDAS, please do not add 2 plus 3 first. The first thing you have to do is take 3 and distribute. Okay, that will give you 2 plus 3n minus 3. And now you can combine the like terms. And your formula is a sub n is equal to 3n minus 1. Example number 3, writing the terms of an arithmetic sequence. The fourth term of an arithmetic sequence is 20, and the 13th term is 65. Write the first 11 terms of this sequence. All right, so the first things first, what do we know? Well, we know, according to what's written here, is that a sub 4 is equal to 20. The fourth term is 20. We also know that the 13th term, or a sub 13, is 65. All right. What we need to know in order to write an equation, or at least know what the common difference is between the terms, is to find d. And if you have not recognized this pattern yet, if I go back to the previous example, this has a linear pattern. Remember, this is your recursive formula, and if you write the explicit formula, it will be in y equals format. So y equals 3x minus 1, where x represents the number of term in the sequence. In other words, it represents the 4. And y represents the outcome. My outcome is 20, or the number in that sequence. So for the fourth term, I have an output of 20. For the 13th term, I have an output of 65, which leads me to believe that d, which was 3 in this case, can be found by finding slope, just like we did for linear equations. So to find slope, you're going to find the difference between the y values, which is 65 minus 20, and divide them by the difference of the x values, which is 13 minus 4. Okay, hopefully you're following me so far. 65 minus 20 is 45. Divided by 13 minus 4 is 9, which gives me 5. 45 divided by 9 is 5. So the common difference between the terms is 5. Well, if A4 is 20, that would mean that A5 is 25. That will mean that A6 is 30, A7, 35, and then 40, and then 45, and then 50, and then 55. And if you skip down to 13, well, then 12 will be 60, 13 will be 65, because you're counting by fives. To go backwards, you just subtract the 5. So this is 15, this is 10, and A1 would have had to be 5. Example number 4, using a recursion formula. Find the 9th term of the arithmetic sequence that begins with 2 and 9. So here's an example where it wants us to find a number specifically a specific term in the sequence. Okay, a specific term in the sequence. So we are going to assume that A1 is 2 and A2 is 9. So to calculate the D, which is what we need to write the equation, you take this last term, which is 9, minus its previous term, which is 2, and you're going to get 7. Okay, so if we remember from a couple of examples ago, or even from the previous example number 2 rather, AN is equal to A1 plus D times n minus 1. So now we have the two pieces of information that we need that we can actually substitute, A1 and D, and we get AN is equal to A1 is 2 plus D, which is 7, times n minus 1. And then we simplify this by distributing first. 2 plus 7n minus 7. And then we combine like terms. And so our formula is AN equals 7n minus 5. Okay, we're not done yet because the directions told us to find the 9th term in the sequence. Now, of course, you can go from 2 to 9, and then 9 and add 7 more to it, and then add 7 more to that, and then add 7 more to that. But then what's the purpose of finding the equation if you're going to do all of that? So the easiest thing to do is, now my number is 9 because I'm looking for the 9th term in the sequence. So I need to plug in 9 for n into the equation. So 7 times 9 is 63. Subtract 5 from that and you get 58, And that concludes this lesson.